This isn't science fiction anymore. China has revealed a flying military suit that turns soldiers into airborne weapons. And global armies are taking this threat very seriously. Join us and let's uncover the Chinese flying suit that's terrifying militaries worldwide. Let's go.
Number 12. Atlas humanoid robot that moves like an Olympic gymnast. Boston Dynamics pushed robotics into territory that seemed impossible with Atlas, a humanoid robot that performs standing backflips, parkour courses, and coordinated dance routines with multiple robots moving in perfect synchronization. Standing 5 feet tall and weighing 190 pounds, Atlas represents the pinnacle of bipedal robotics, with 28 hydraulic joints providing human-like range of motion. The machine processes data from cameras and LiDAR sensors to understand its environment in 3 dimensions, planning movements and adjusting balance in real time. Watch Atlas navigate an obstacle course and you see something that moves less like a machine and more like an athlete. It jumps between platforms, maintains balance on narrow beams, and recovers from pushes that would topple traditional robots. The control systems handle dozens of calculations per second to keep the robot upright, coordinate limb movements, and plan safe paths through complex spaces. Each new video Boston Dynamics releases shows Atlas doing things that seemed impossible months earlier. The progress happens so fast that predictions about robot capabilities keep getting outdated. The implications extend far beyond entertainment value. Humanoid robots excel in environments designed for human bodies. They climb ladders, fit through doorways, use standard tools, and navigate stairs without requiring infrastructure modifications. Disaster response teams could deploy Atlas-type robots into collapsed buildings, radioactive zones, or areas contaminated with biological hazards. Construction sites benefit from robots that lift heavy materials, work extended hours without fatigue, and handle dangerous tasks that injure thousands of workers annually. Military applications remain mostly theoretical but obviously significant. Imagine squads of robots that breach buildings, clear mines, or conduct reconnaissance without risking human lives. The technology faces major obstacles before widespread deployment becomes viable. Battery life limits operations to about 2 hours, the robots cost millions of dollars each, and reliability under field conditions remains unproven. However, the pace of improvement suggests these limitations will disappear within years rather than decades.
Number 11. China's armed robot dog QBZ-97, drone-deployed weapon. October 2022 brought footage that made military analysts worldwide sit up and take notice. China demonstrated a robotic dog armed with a machine gun being airdropped from a drone onto a building rooftop, where it immediately stood up, scanned the area, and locked on to potential targets. The QBZ-97 light machine gun mounted on its back fires 650 rounds per minute with effective range over 300 feet, giving this 4-legged weapons platform serious firepower. But the real innovation isn't the gun, it's the delivery method and tactical possibilities it opens. Traditional attacks on fortified positions require troops to fight through ground-level defenses, exposing them to concentrated enemy fire. This system bypasses all that by putting armed robots exactly where defenders don't expect them, turning rooftop positions into instant firing platforms for 3-dimensional assaults. The demonstration video showed additional elements that multiplied the tactical advantages. A spherical reconnaissance robot that rolls through buildings feeding live video back to commanders, allowing real-time mission planning based on actual enemy positions rather than guesses. Remote control systems let operators manage these robots from safe distances, coordinating multi-robot attacks that overwhelm defenders from multiple unexpected angles simultaneously. While current versions still require human operators making firing decisions, the integration of autonomous targeting systems is clearly the next step, raising urgent questions about machines making kill decisions without direct human oversight. These robotic systems excel at adapting to different terrain types and operating in conditions that incapacitate human soldiers, toxic environments, extreme temperatures, areas with chemical or biological contamination. The strategic calculus shifts dramatically when military planners can deploy lethal force without risking human casualties on their side, potentially lowering the political cost of military action in ways that could make conflicts more frequent.
I'm going to ask you a simple question. Are you a naturally curious person? If you're watching, I'm pretty sure the answer is yes. This space is made for people like us. To ensure you're always part of this community and receive all our latest discoveries, you just need to do one thing: subscribe to the channel. It's the best way to stay connected with us. Okay, now that you're part of our Legion of the Curious, let's move on to the next item. Number 10. March 8. Exoskeleton by Delft University, Self-Balancing Mobility Aid. Delft University of Technology unveiled the March 8 exoskeleton in July 2023, representing breakthrough innovation for individuals with spinal cord injuries who previously couldn't walk independently. This device eliminates the need for crutches or external support, using advanced self-balancing systems that closely mimic natural human movement patterns. The system dramatically improves user quality of life by restoring independent mobility. Leg attachments support the torso and limbs, while integrated sensors detect movement intentions, and electric motors assist the walking process with customizable settings for individual users. Specific details like lifting capacity and battery life remain undisclosed as the prototype undergoes continued development, but early demonstrations showed impressive terrain adaptation and variable assistance levels. The device handles different ground types and inclines while adjusting support based on user needs and environmental conditions. As an early-stage prototype, significant improvements and refinements are expected before widespread deployment becomes viable. The technology represents hope for mobility-impaired individuals worldwide, potentially restoring capabilities many thought permanently lost. Military applications are obvious. Soldiers injured in combat could return to active duty with mechanical assistance compensating for damaged limbs or compromised physical capacity. The psychological impact of restored mobility extends beyond pure physical capability, giving users independence and dignity that wheelchairs and crutches cannot fully provide. As development continues, these exoskeletons will become lighter, more powerful, and more intuitive to operate, eventually becoming as natural to use as the human body itself.
Lockheed Martin's Hulk that makes soldiers carry twice their weight. Lockheed Martin entered the powered exoskeleton race with Hulk, the human universal load carrier, a lower body system that helps infantry soldiers haul 200 pounds across any terrain for distances up to 12 miles on one battery charge. Unlike full body suits, Hulk focuses exclusively on leg support, using hydraulic actuators and a titanium frame to transfer weight directly to the ground through the exoskeleton's feet rather than the soldier's body. This design allows soldiers to move at 7 miles per hour sustained speed, with 10 mile per hour bursts when needed. The system handles deep squats, crawls, and upper body movements without restricting natural motion. An onboard microcomputer analyzes the wearer's movements in real time, adjusting support levels automatically to maintain synchronization between human and machine. Soldiers can remove and pack up the entire system in under 30 seconds, crucial when rapid mobility becomes more important than carrying capacity. Lockheed Martin licensed the original Berkeley Bionics design in 2009 and spent years ruggedizing it for military applications. The U.S. Army Natick Soldier Research Center conducted extensive testing starting in 2010, measuring metabolic costs and energy expenditure to determine whether the system actually reduced physical strain or just redistributed it. Results showed that Hulk decreased oxygen consumption by 15% when soldiers carried 81-pound loads at walking speed, proving the concept worked physiologically. The modular design lets users swap components quickly in the field, adapting the exoskeleton for different mission requirements. While military applications drove initial development, industrial and medical uses became increasingly important as the technology matured. Warehouse workers, construction crews, and shipyard laborers all benefit from technology that prevents injury and extends working capability. The medical sector particularly embraced these systems for rehabilitation, helping injured individuals rebuild strength and mobility faster than traditional therapy methods allow.
Number 8. Robotic exoskeleton boots, powered walking technology. Walking long distances while carrying heavy loads destroys soldiers' bodies over time. Knees give out, backs fail, and by the time troops reach their objective, they're too exhausted to fight effectively. Robotic exoskeleton boots tackle this problem head-on by augmenting every step with mechanical power that feels natural but delivers superhuman results. Sensors embedded throughout the boot system detect exactly how your leg is moving, what angle your foot hits the ground, and how much force you're generating. Micromotors and actuators then inject additional power at precisely the right moment in your stride, effectively giving you a boost with every step. The result feels like walking downhill even when you're climbing upward, or carrying light gear when your pack weighs 80 pounds. Industrial workers were the first to adopt this technology, using it to handle heavy equipment and work longer shifts without the usual physical breakdown. Military applications proved even more valuable.
Soldiers can march farther, move faster, and arrive at objectives with energy reserves intact. The artificial intelligence running these systems learns your walking pattern over time, adjusting assistance levels to match your natural rhythm and compensate for fatigue as missions drag on. Lightweight carbon fiber construction keeps the added weight minimal, while modular battery packs provide 8 to 12 hours of continuous operation. Physical therapy applications show remarkable promise too, helping injured soldiers and veterans rebuild strength and mobility faster than traditional rehabilitation methods allow. The technology essentially democratizes physical capability, letting anyone perform at levels previously reserved for elite athletes. As costs drop and designs improve, these boots are transitioning from experimental prototypes to standard issue equipment for frontline units operating in demanding environments.
Number 7. Corridor Crew's Robot Soldiers film, The Future of Warfare. Picture something wild for a second. A short film drops online and suddenly everyone's talking about robots that don't just follow orders, but actually think, adapt, and respond like they've got brains of their own. That's exactly what Corridor Crew delivered when they unleashed their vision of future warfare through digital magic. This wasn't some big-budget Hollywood production with unlimited cash, just a talented group showing us what robotics could become when artificial intelligence meets battlefield reality. Their creation sparked debates across tech forums and military circles because it touched on something real, something that's already happening in labs and testing grounds worldwide. These digital soldiers moved with precision that felt almost human, reacted to threats faster than any person could, and operated with a cold efficiency that both impressed and unsettled viewers. The film showed robots making split-second combat decisions, coordinating complex maneuvers, and executing missions with zero hesitation. While this remains artistic vision for now, the technology powering similar concepts is advancing at breakneck speed. Companies and militaries across the globe are pouring billions into autonomous systems that blur the line between tool and warrior. The ethical questions hanging over this development are massive, touching everything from battlefield accountability to the very nature of human conflict. But here's the kicker. While we debate the morality, the technology keeps marching forward, getting smarter, faster, and more capable with each passing month. Defense contractors are already testing prototypes that combine mobility with deadly firepower, creating machines that can navigate urban environments, breach buildings, and engage targets without direct human control. The future Corridor Crew imagined isn't as far off as you might think. Number 6. Bloodwing System, Chinese Robot Dog Aerial Deployment. The Bloodwing demonstration video showcased a tactical innovation that military strategists found both brilliant and disturbing. A robotic dog carrying a light machine gun gets dropped from a drone onto a building rooftop, immediately establishing a firing position capable of delivering 650 rounds per minute at ranges exceeding 300 feet. This capability enables surprise attacks on vulnerable enemy positions from completely unexpected directions, rooftops, rear areas, elevated positions that traditional ground forces can't easily access. The video revealed sophisticated tactical integration, control panels for operator oversight, spherical reconnaissance robots that roll through interior spaces transmitting real-time video feeds, allowing forces to plan precise room-by-room assaults before committing human troops. This system integration increases battlefield complexity dramatically and raises serious concerns about fully autonomous weapons operating with minimal human supervision. The ethical and practical risks multiply when machines capable of lethal force make engagement decisions based on programmed algorithms rather than human judgment. The technical capabilities demonstrated suggest Chinese military robotics are rapidly advancing towards systems that can conduct complex multi-phase operations, combining reconnaissance, infiltration, and direct action with decreasing human involvement at each stage. While current systems remain remotely operated, the progression toward full autonomy appears inevitable as artificial intelligence and sensor technology improve.
Number 5. Tactical Jetpack Suit, Personal Flight Technology. Flying used to belong exclusively to pilots in multi-million-dollar aircraft. Not anymore. The tactical jetpack suit brings vertical flight capability down to individual soldier level, transforming how military forces think about mobility and rapid response. Powerful jet engines mounted on the arms and back generate enough thrust for vertical takeoff, high-speed forward flight, and precision hovering in tight spaces where helicopters can't operate.
Operators can zip across battlefields at speeds conventional troops can't match, reaching wounded soldiers in record time or accessing rooftops and mountain ridges that normally require hours of dangerous climbing. The control system uses sophisticated gyroscopic stabilization combined with intuitive body movements. Lean forward to accelerate, shift your weight to turn, subtle adjustments maintain hover. Military applications extend far beyond flashy demonstrations. Imagine rescue teams reaching disaster survivors trapped on upper floors of collapsed buildings, or special forces operators inserting onto target rooftops without the noise and vulnerability of helicopter insertion. The modular design lets users swap components based on mission requirements, adding extra fuel capacity for extended range or mounting specialized equipment for different scenarios. Safety features include automatic stabilization that prevents dangerous spins or rolls, plus emergency landing protocols that activate if power or control fails. Battery and fuel technology improvements keep pushing flight times longer and payload capacity higher, making these suits increasingly practical for real operations. Current models already demonstrate 20-minute flight duration with room for weapons and tactical gear. The psychological impact on enemies seeing soldiers literally flying into combat positions adds another layer to the tactical advantage. Traditional defensive positions designed to stop ground-based assaults become instantly obsolete when attackers can bypass walls and obstacles by simply flying over them.
Number 4. Hyperstealth Quantum Stealth Technology, Thermal Signature Invisibility. Security experts warn that advanced concealment technology could be exploited for criminal activities and terrorism, potentially requiring enhanced public surveillance systems and specialized sensors to detect hidden threats. The possibility of invisible vehicles and people operating in public spaces forces society toward either increased monitoring that detects concealed objects or accepting vulnerability to unseen threats. Companies like Hyperstealth Biotechnology are pushing boundaries further with quantum stealth technology that conceals thermal signatures without power requirements, using specially designed lenses that bend visible and infrared light simultaneously. This development shows that complete invisibility is approaching practical reality rather than remaining theoretical possibility. Future applications could integrate this technology into multiple systems and products, from military equipment to consumer devices. While commercial camouflage devices exist today, they represent crude approximations of true military-grade concealment. The sophisticated systems under development by defense contractors worldwide operate on fundamentally different principles, with dramatically superior performance. Metamaterial applications extend beyond invisibility into areas like improved vehicle efficiency, enhanced autonomous driving systems through better sensor performance, and optimized communication networks that manipulate signal propagation. These materials promise to reshape multiple industries, while military applications receive the most development funding. Three-dimensional holographic displays using metamaterial principles could revolutionize human-computer interaction, projecting tangible-seeming images into physical space for applications in medical imaging, architectural visualization, and industrial design. Entertainment applications alone could drive significant commercial investment, with movie studios and game developers eager to create immersive experiences that transcend current screen-based limitations. The cultural impact of technologies that manipulate visual reality challenges our fundamental assumptions about what we can trust our eyes to tell us accurately.
Elon Musk unveiled Tesla's humanoid robot with the bold claim that eventually these machines will outnumber humans and cost less than a car. Standing 5 feet 8 inches and weighing 125 pounds, Optimus uses Tesla's self-driving AI adapted for bipedal walking instead of vehicle navigation. The robot employs the same neural networks, camera systems, and processing chips developed for Tesla vehicles, giving it sophisticated environment perception and decision-making capability. Early prototypes demonstrated basic tasks like sorting objects, watering plants, and carrying boxes, showing potential for useful work rather than just impressive demonstrations. Musk envisions Optimus handling repetitive household chores, factory work, and eventually becoming a general-purpose assistant that costs around $20,000. Skeptics point out the enormous gap between current capabilities and Musk's promises, noting that robots still struggle with tasks 5-year-old children handle easily. However, Tesla's unique advantage comes from manufacturing scale and AI infrastructure. They produce millions of vehicles using automated factories and train neural networks with data from billions of miles of real-world driving. Applying this industrial capability to humanoid robots could overcome obstacles that stopped previous attempts.
The company demonstrated rapid progress, moving from crude prototypes to relatively polished robots in under 2 years. Multiple Optimus units working together at Tesla facilities now perform actual factory tasks, suggesting the technology transitions beyond pure research into practical application. Military interest in general-purpose humanoid robots remains strong, despite public focus on specialized combat systems. Robots that handle logistics, perform maintenance, and support operations without requiring custom equipment or training would provide enormous operational advantages. The ability to deploy robots that use standard tools, vehicles, and infrastructure means existing supply chains and procedures require no modification.
Number 2. Metamaterial Smart Materials Active Camouflage Systems. The challenges in deploying full vehicle invisibility are massive, but solvable. Covering an entire military vehicle with displays and sensors creates complicated maintenance issues. Any damage disrupts the camouflage effect and reveals the vehicle's position. Power requirements for running thousands of display elements continuously drain batteries that could be used for propulsion and weapon systems. Researchers are pivoting towards smart materials that change color or transparency properties without constant power input, materials that respond to environmental conditions automatically and integrate directly into vehicle paint and armor, rather than requiring separate display panels. This approach increases durability while reducing power consumption and complexity. Component miniaturization allows sensor and display elements to become small enough for direct integration into vehicle surfaces, creating seamless camouflage systems that survive combat damage better than external panel arrays. Beyond pure invisibility, these metamaterial technologies promise improvements in vehicle aerodynamics, autonomous driving sensor accuracy, and communication system efficiency. Controlling electromagnetic wave behavior lets engineers reduce drag, enhance LiDAR and radar performance, and optimize signal transmission. The civilian sector sees enormous potential in three-dimensional holographic displays that project images into thin air, revolutionizing how we interact with digital information in medicine, engineering, and design work. Entertainment industries are already exploring these technologies for movies, games, and immersive experiences that blur lines between physical and digital reality. Privacy and surveillance concerns multiply dramatically as invisibility becomes a practical reality. Laws and regulations struggle to keep pace with technology that lets individuals and organizations hide from view, necessitating new detection methods and legal frameworks. A new arms race emerges between concealment and detection, with both sides pushing technological boundaries in escalating competition.
Number 1. Hypershell Exoskeleton, AI-powered outdoor mobility system. Hypershell debuted at CES 2024 as a revolutionary innovation for outdoor enthusiasts who want enhanced mobility in challenging terrain. Weighing just under 6 pounds, the device packs an 800-watt motor that adapts to varying ground conditions, supporting users through difficult climbs, long hikes, and extended treks. A single charge powers assisted movement for over 1,650 yards, providing natural movement enhancement that reduces fatigue without compromising the outdoor experience. The IP54 environmental rating ensures Hypershell handles rain, dust, and rough conditions that would disable less rugged equipment. This represents a quantum leap in outdoor recreation technology, letting users explore terrain previously beyond their physical capabilities while maintaining comfort and extending their range dramatically. The technology enhances interaction with nature rather than replacing it, giving hikers and adventurers tools to push boundaries while still engaging directly with wilderness environments. Military interest in commercial outdoor exoskeletons is inevitable. Technology proven in civilian recreation quickly finds tactical applications when soldiers need similar capabilities in combat zones. The compact, weatherproof design translates directly to military requirements for portable power enhancement systems that soldiers can carry and deploy without specialized vehicles or support equipment. As costs decrease through mass production for recreational markets, military adoption accelerates, creating entire units equipped with powered movement systems that fundamentally change infantry capabilities.
Still curious? Then don't stop now. The next mystery is already waiting for you. Just click the video on screen. I saved it just for you. See you there, curious one.